Welcome everybody. We got a beautiful question. So foremost, let me draw the figure. So the figure is going to be something like this. So we got a semicircle and let me connect the extreme points so that a diameter is created. Now we have to draw a square. Well, it can be a square, a rectangle, anything you want to call it, but the figure is going to be looking something like this. So you have a hit over here. This is a hit here. And there is also a hit at this point. And there is a hit here. So we are expected to find the area of the semicircle. So I'm going to name it as ABCD. Now this distance is given as 2 units. This is given to be as 8 units. Now figure is not to scale. And this is the center. So we are expected to find the area. For that, step number 1, we need to find the radius. So I'm going to take this point as O and this point as E, this point is F. So what I'm going to do is, now clearly OE is equal to OF is equal to R. So if I were to take this distance as R, this will also be equal to R. Okay. Now what I wish to do is, I see that there is a point of contact here, and there is also a point of contact at this end, and also there is a point of contact here. Now what I wish to do is, I would like to drop a perpendicular from F to AB to meet at G. So exactly at this point I'm going to drop a perpendicular, right? Now after I've dropped a perpendicular, now this point is G, right? Now clearly FC is equal to GB is equal to 2 units. This is not of much importance, but just to make an observation. Now from O we will drop a perpendicular to BC. So from O I'm dropping a perpendicular. Well, I said BC, I'm just keeping it as a dotted line to BC. Now clearly I will name this point as H. H is the point of intersection of the perpendicular from O with the perpendicular from F. So that means this angle is 90 degree. Let me take this as I. Fair enough. So I have a triangle here. Clearly we have formed a triangle. Now I'm going to name or call the triangle as OHF. Okay. What I'm going to do now is, this is step 2, or you can call it as step 3 depending on what you have named this. So I will call this as step 2, step 3. Step 3, drop a perpendicular from O to AB such that the perpendicular meets AB at J. So from here you drop a perpendicular. Okay, so now the next step is step 4 is draw a perpendicular from E to OJ such that the line meets OJ at K. So we are again dropping a perpendicular, or I should say drawing a perpendicular to OJ. So we have a 90 degree there. Now you have to observe this point. From here I drew a perpendicular to FG. From here again I drew a perpendicular. So let me call this as K. Right, I drew a perpendicular EK such that there is an intersection at this point at K. Okay, fair enough. So this is starting from O, this is starting from E, all from the same line. So the angle created here will be the angle created here. So now what do you observe here? You observe that step number 4, we observe that by angle, side, angle, or you can also angle, side, angle, or I think you can call it as angle, angle, side, right? So depending on what you like, I think I will call it as, you can also call it as side, angle, angle. So by angle, side, angle, right? Because the fact is that the angle that is created here will also be the angle, the same angle created here. So this angle will be same as this angle, and this angle will be same as this angle. So it's fair enough to state angle, side, angle, right? Or angle, 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 by any direction. Either you want to go by angle, side, angle, or angle, angle, angle. We have, what do we have? Triangle EKO is congruent to triangle OHF. Now let me draw this congruency properly. Okay, angle EKO is congruent to angle OHF. Now this is all important point that we will have to be utilizing. So what is the meaning of this? The meaning of this is triangle EKO is congruent to triangle OHF. So by that we would be able to solve this question. Now clearly I'm using this part. Clearly OJ is equal to R and EA or AE is equal to 8, which is equal to JK. Now so this is going to be 8. This entire thing is R, right? That's a radius. Now this entire thing is equal to R means this is 8 means what would this be? This is going to be from R you take away 8. Fair enough. Now from the center a line is drawn to the point on a circle. So also OI is equal to R and FC is equal to, you remember I have taken, or I should say it's given FC is equal to 2. Now FC is equal to 2 means this is also equal to HI, right? So this would mean OI is equal to R, and what is OH would be? OH is going to be R minus 2, right? So this would mean OH is equal to R minus 2. Fine, fantastic. Now what I'm going to do is, since triangle EKO is congruent to triangle OHF, right? This means HF is equal to KO, which is equal to R minus 8. So this is R minus 8, right? Since triangle OHF is right angle triangle, this means we can use Pythagoras, right? By Pythagoras theorem we get, what do we get? OH squared plus FH squared is equal to OF squared. OF squared is R squared, OH squared is R minus 2 squared, and HF squared is R negative 8 squared, right? Expand this. This is R squared negative 4 times R positive 4 plus R squared negative 16R positive 64 is equal to R squared. This and this can be cancelled. Now negative 4R, and let me use this part, negative 4R and negative 16R is negative 20R. That's fine. Positive 64 and 4, that's 68. And then you got an R squared is equal to 0. So this is a quadratic equation. So let me use this part. We get, so what do we get? We get R squared negative 20 times R positive 68 is equal to 0. So use quadratic. Therefore R is equal to plus or minus root of B squared, that's 20 squared is 400, negative 4 times A C 68 divided by 2 times A. So I have 400 and multiply with 4 times 68, 6, 8 4s are 32, 3, 24, 25, 26, 27. So we subtract from 10, you take away 2, you get 8. From 9, you take away 7, you get 2. From 3, you take away 2, you get 1. 128 plus or minus, I can't take negative because it will be, the entire quantity of radius will become negative. So I take only positive, right? Because this is negative, this is root of 128. So if I were to take negative, so if I were to use the calculator, let me see what is the square root of 128. I want to use my calculator. So I'm checking for 128. Okay, negative is also possible because 128 is approximately, see, root of 128 is approximately 11.3137. I'm going to approximately take it as 11.314, right? So if you take 11.314, two radius are possible, right? So let us check and see which of these radius is going to be a feasible one, right? Because out of this only one alone is going to be feasible. So 11.314, if I were to take 20 positive 11.314 divided by 2, this is going to give me 31.314 divided by 2, which is going to give me 1, 5, 6 and 5 and 7. So it's again an approximate value only we are writing, 15.65. This is the value, 16.657. So 16.657 is the radius. Now let me see the other value. So R is equal to, from 20 I subtract 11.314, it's 20.00, 10, 10, 6, 9, 8, 9, 6, you got a 9, 8 and 1. So this is what I get. So I divide by 2. So R is 4.32 and 3. So this is the value of R I am getting. R is equal to 4.323. Now clearly with this is not going to happen. So I drop this, right? Because with one part being 8 units, we are not going to get a semicircle which is going to be hitting these ends. That's not going to happen. So this is the correct value. Now we are asked to find the area, right? So area is equal to pi r squared is the area of the circle, but a semicircle you divide by 2. So it's going to be pi over 2 times, I've taken approximate value, so 15.657 times 15.657. So if you can use your calculator, if you were to use your calculator, let us check what is the value. I'm going to use my calculator and see what happens when 15.657 is divided by 2 and then multiplied by 15.657. So we're getting a value of approximately 122.57 pi, right, square units. So that is the area of the semicircle. Thank you everybody. Like, share and give your comments. So you give your comments and also subscribe to our channel. Until we meet again, enjoy your night. Thank you.